Okay. Okay, we are recording. So first of all, I want to remind you that you have the lab to do. Unfortunately, I still have people that have not expressed their preference for the lab. It's important that you do that, no? So the lab that you have to do is, let me see if I find it here. Do you remember which one it is? Lab 7, Lab 8? But I have a different enumeration here. It's not this one, no? Is it this one? This one?
That's the one.
Is the one? Okay, so yeah, you have a serial connection to do. Let me do, for example, the connection between R4 and are you sure it's this one, R4 and R6? Let me see. I have doubt it is this one. Yeah, it should be this one because. Okay, I show you in all cases in this one. So I'm going to start GNS3, create a new project. Okay, so let's call, for example, lab 01, the project. So I need some router. The version of GNS3 that is in the cloud have more router. This only have a 3640, but you have a 3725. And in the lab, they ask you to use a, oh, I know where it is, a 3725. So I have it here, should be the lab topology. Yeah, which very similar to this one. So this is the lab. Okay, so here they say use the 3725. Okay, so sorry, here I should have downloaded the correct version of GNS3. I don't have it, so I'm going to do it with the 3640 that we have here. So I want to do just this part because there is a question how we do the serial connection. So I'm going to put to router. Okay, this one I'm going to rename it R6. And this one to rename it R4 because I want to do the connection between R4 and R6. We have some PCs. You can put them. So here I have a fast Ethernet 01 and a serial 10. So I have to be sure that I have that. So I'm going to go, if I put the cursor here, this is a modular router. And in the slot, I have not put anything. So the router is off. While the router is off, I can open the router. So opening the router, you go here in configuration, it simulates that you open the router. And you can see the slot. They are all empty. So in slot 0, I need a network module 1 FETX, 1 fast Ethernet. If I just do that, if you look in this moment, it will have, you can see that we have a fast Ethernet 00. I need a fast Ethernet 01. So in the other router, you will have 01. Unfortunately, here we will not have 01. I need a fast Ethernet 00 on router 4. So in the slot here, I put this module, and I need some serial module. So they have to be in slot 2 because they are called 20, 21, 22. So in slot 2, I'm going to put this module, network module 4T, network module 4T. And here in slot 1, I need serial. So I come back here, I open the router, and in slot 1, I'm going to put the network module 4T. So now I can do the serial connection. When you click, it will show you all that. So for example, I want serial 21, which is this one, connected with serial 10, which is this one. So the connection is done. You power on the router and you configure, no? So let me configure it just to show you at this level. So they are both booting. They will take a few seconds to boot. Let me open the console of both of them. So here we have R4. So of course, you need to do more than just putting the IP address on enable the interface. No, you need to do more than that. So let me type here enable, configure terminal, host name. This will be R4. Okay, so the prompt already helped me. So I want to configure this interface. This is serial 21, interface serial 21. I'm going to put an IP address. The IP address is 205.370/26. So 205.370/26. So 255.192. No shutdown, of course. Here I am in serial link. You have something that is called a DCE and a DTE. So this side is the DCE, and this side is the DTE. So there is a command that is clock rate. The command clock rate, you put it on the size of the DCE. So in this interface, in this network, sorry, on the size of R6. In this network, on the size of R3. In this network, which is a serial connection, on the size of R4. So in R4, I will have to do it also in this interface. Okay, so no shutdown. This interface is ready, but does not mean that I have finished to configure the router. You have much more to do. Okay, so let me go to R6, enable, configure terminal, hostname, R6. I want to configure this interface. So I go to inside the interface, it's a serial 10. I put the IP address. The IP address is 200.5.379/26. So 255.255.255.192. And I'm the DCE. So I need to type the command clock rate. See, 128 kbps, which is 128,000. Okay, so this 128, you type it on this side because I'm the DCE, data communication equipment. The other one is the DTE, data terminal equipment. Okay, so you are done to configure, for example, this interface. And of course, now I should be able to ping the other side, no? Which is 205.370. I should be able to ping it. So the first one didn't work, the second one don't work. Oh. Did I put in R4 no shutdown? Yeah, I did. So show IP interface brief. So it is up down. That's a problem. We should have up here and it is up down. So let me see. I did. In R6. Oh, I did also do no shutdown here. Okay, so show IP interface brief will show it is administratively down, which means that I forgot to type the no shutdown in R6. So if you look at the interface of R6, this interface, the serial 10, do have the correct IP address, but it is administratively down. It has to be up. So let me go back, configure terminal, interface serial 10, and put no shutdown to enable it. So it will go to up. Now it is in up. As you can see, it's worked properly. So I should be able to ping. So as you can see, admiration 5 times, because by default, Cisco do it 5 times. But if you want to do it a little more time, you use repeat and you say the number of times that you want to do it. So I was able to ping from R4 to R6, no? And well, you keep going and configure more, no? Is it okay? Okay. Remember, I need a configuration of what you have done. So take some screenshot, or in the report, specify why we type a command, what is the objective of a command. You have to put that in your report, no? When is this due? Saturday, no? Okay, so be sure that you upload it for Saturday. Okay, we are going to do some exercises. So we will do exam number 2. So next week, we will do quiz 2. I think we can do it on Thursday next week. So we will do exam 2 on Tuesday in 2 weeks. I will send an email with the date. But next week on Thursday, which means in 10 days more or less, or 9 days, I should say, we will have quiz number 2, okay? And the exam will come after that. Okay, let's start with exercise 69. If you have any exercise that you could not do, let me know. We can go over them. 69. Okay. Let me put it in the same page, so we have all the information in the same page. Okay. So question 69. A network administrator config the router with the following command, which is IP route 172.16.1.0, 255.255.255.0, 172.16.2.2. Okay, how will this route appear in the routing table? So some of the solutions show a C, others show a S. What is the difference between C and S? When a route will appear in the routing table with a C? When it's directly connected. For example, if I go back to the lab and I do show IP route, which will show me the routing table, this router should have only one entry in the routing table. And this entry have to appear with a C of directly connected. Look at it here, C of directly connected. So C here, they tell you, is directly connected. S is static. So every time that you go to an interface and you type an IP address, this will add an entry in the routing table. And this entry will appear as a C, because this network is directly connected to me. So it appears with a C. So for example, if I go back, let me open the PowerPoint again. I go back to this lab, to the topology. Here we just configure R6. So R6 will have what if you configure it? It will have two C, two entry with C. So give me an example of an entry with C. Why R6 have two entry with C in its routing table? Because it is directly connected to this network and directly connected to this network. So it will have two entry with C. So one entry will say, the first entry will say what? Give me one of the two entry. For example, the entry that corresponds to this interface will say what? The network 200.5.3.128/26 is directly connected to Fast Ethernet 01. And this entry will say what? The network 200.5.3.64/26 is directly connected to serial 10. So look at the network 200.5.3.64/26 is directly connected to serial 10. Okay? This is what I can see there. Okay, if I ask you, for example, when I finish to configure router, for example, router S4, in the routing table of router S4, router R4, sorry. In the routing table of router R4, how many entry with C we will have when I finish the configuration? We'll have 4, isn't it? Because R4 is directly connected to 4 networks. So there will be a C for this network. And this C will say what? The network 200.5.3.64/26 is directly connected to serial 2/1. Then there will be a C for this network. It will say what? The network 5.5.80/24 is directly connected to serial 2/2. Then we'll have another C for this network. It will say the network 5.4.23.0/24 is directly connected to Fast Ethernet 0/0. And we will have a 4C in the routing table that will say the network 174.40.0/22 is directly connected on serial 2/0. Isn't it? You understand why I say the network 174.40.0 is direct /22 is directly connected on serial 20. Why I put 40 here? That was the objective of the course, the first month. If I give you an IP address with the net mask, you should be able to give me the network that this IP address belongs to. So this IP address is 170.442.1. It belongs to the network 170.440/22, no? So you will be 4C in the routing table of this router. If I ask you the routing table of R2 will have how many C? 3C. Because it's directly connected to 3 networks. The routing table of R1 will have 2 entries with C, because R1 is directly connected to this network and directly connected to this network, so to C. Okay, so let's go back to the question. So in which case I will see, so C is when I'm directly connected. So you went inside the interface, you type the command IP address, no shutdown. IP address and IP address on a net mask. Then you type the command no shutdown. Now, when I will see a S in the routing table, when you type the command IP route. So here we are typing the command IP route. If you type the command IP route, it will introduce a S in the routing table. So if the person typed the command IP route 172.16.10.255.255.255.0 172.16.22, it will put an S in the routing table. So what are the possibilities? We can suppress the C. So we have two possibilities. It is either B or D. Which one of the two it will be? It will be B or C?
It'll be D.
Correct, it will be D. Okay. For it to be C, to be B, the person will have to have typed this command. IP route on serial 0/0. If the person typed this command, it will appear like that. It says that if you want to reach the network 172.16.10 / something, we don't see it in this line. Or it should not say directly connected. It should say, yeah, directly connected. Oh yeah, maybe it should say directly connected. But the person should have typed not an IP address, but an exit interface. If you want to reach the network, this remote network, you send the packet out this interface. So the outgoing interface is serial 0/0. Okay, exercise 70. Refer to the graphic. Which command will be used on router A, which is this router, to configure a static route? To direct traffic from LAN C, so LAN C is here, to LAN A, to LAN C. So I need to type a command here in A so that I can reach LAN C. So what will be the command that you need to type? Okay, let's do the configuration of router A. What will be the configuration of router A? So first, enable will take you what? In privilege mode. Configure terminal will take you in global configuration mode. Then you need to enter the interface. So let's say that this interface is serial 00. If it is the case, you will have to type interface serial 0/0. Enter. Then you need to put an IP address. So you will type IP space address space 192.168.3.1 space 255.255.255.0. Enter. Then what? No shutdown. So you enable the interface. If I am the DCE, here they don't say who is the DCE. But in a serial connection, you have a DCE and a DTE. If I am the DCE, I have to type the command clock rate. Then exit. I exit this interface. Then I go to this interface. Let's say that this interface is fast Ethernet 2/0. So I will type interface fast Ethernet 2/0. Then I will type what? IP space address space 192.168.2.1 space 255.255.255.0. This is the configuration of the interface, the IP address and the net mask. Then no shutdown. Then exit. I'm done with the configuration of the interfaces. Now what happened? That A only know this network on this network. So if A receive a packet for this network, it doesn't know where is this network. Or if A receive a packet for this network, it doesn't know where is this network. Or if A receive a packet for this network, it doesn't know where it is. So we need to give more information to A. We need to tell A, okay, that's true, you are directly connected to this network and this network. But there are remote networks. There are 3 remote networks. To tell A about the remote network, we need to use the command IP route. So we'll need the command IP route for this remote network, for this remote network, and for this remote network. Because if we don't tell A what to do, cannot guess it. It's not intelligent. It doesn't see you see the diagram, but A doesn't see that. Doesn't have eyes to see the diagram. It's not intelligent, so you need to tell A everything. So let's tell A about this network. So what should we type if we want to tell A that there is a LAN that is called LAN B? We need to type the command IP route. So this network is 192.168.6.0 space 255.255.255.0 space. What should do A if we want to reach this network? It have to send it out this interface. So we can put, let me show you, we can put several commands. We can choose. Let me add them here. Maybe here. So 6. We can put, for example, 3.2. This is a solution. This is with a next hop. Another solution is, instead of saying the next hop, the output interface. So we say that, suppose that this one is called serial 00. And the third solution will be that we type in A this command, 192.168.3.2. What is the difference between the first one, the second one, and the third one? Okay, the second one and the third one are a little better because they don't need a recursive lookup, a second search. The first one needs a second search because in the first command, you did not specify the output interface, the outgoing interface. So the router have to make a second search in the routing table to get the outgoing interface. It have to find that the outgoing interface is going to be this interface. Let's say that it's serial 0/0. Now here in this, you did specify the output interface. And here you did specify the output interface and the IP address of the network. So in a serial link, where there is only 2 devices, the IP address of the next hop is not necessary, because if I send something out here, there is only one possible destination, because it's a point-to-point connection. A serial connection is a point-to-point connection. So what I send, there will be only one possible recipient. Now, if the connection is an Ethernet connection, we can have several recipients. So it's better in an Ethernet connection to also specify the next hop address, the address of the next router. So of the three possibilities, these two are better. Doesn't mean that this one is not good. It's work also, but it's consume more resources on the router because it have to make a second search, a recursive search. Okay? So we need to specify that if we want to tell A that there is this network. What command we need to type in A to specify that we have a remote network, which is 192.168.40/24. Which of these command? So of course, the last three one don't correspond to 192.168.40. So I can just discard them. Okay, because we are talking here about the network 5, the network 3, and the network 3. We want to tell A there is a remote network which is 192.168.40/24. So it has to be one of these two. And of course, what should do A if you want to reach this network? It have to send it to B. This is the only path. There is no redundancy. Since there is no several way to go from A to this network, there is only one way through B. I have to send it to B. So send it to B, I can say, send it out this interface, or I can send it to 192.168.32. So the solution, of course, will be this one. That's the solution, no? Okay. It's okay? Let's see question 71. So they say, refer to the exhibit. The network administrator need to configure a default route on the border router. So this router is called border. This is a router that belongs to the company that is there. And this router is connected with the router of the ISP, the Internet Service Provider. Okay, so we need to put a default route saying that if the destination is not within my company, send it to the internet. Of course, it is not within my company, it is in the internet. Okay, it's why we need a default route. Which command would the administrator use to configure a default route that will require the least amount of router processing when forwarding the packets, packets? So let's see the possibility. We have IP route 0.0.0.0 for the net mask is 0.0.0.0, which means /0. And we have that 192.133.219.5. Can this be a solution? So where is this IP address? It's my IP address. So if I want to reach the internet, I cannot send it to myself. So of course, this is not a solution. If I want to reach the internet, I am the border router, I need to send it to the ISP router. So this is not a solution. So we have another solution, which send to 198.133.219.6, which is send it to the ISP router. This is a solution. Now, is this the better solution? They say that require the least amount of router processing. This, I didn't specify the exit interface. Since I did not specify the exit interface, the router will have to do a second search to get the outgoing interface. So this will consume more recurses of the router. So it's a solution, but it consumes more resources. Let's see the other possibility. So this possibility say send it out interface serial 001. Correct. So this will be the best solution. On the other say, send it out serial 000. I don't have serial 000. So I cannot send it out serial 000. So of course, this is not a solution at all. So I'm going to do that. So there were two possibilities, this one and this one. Both are correct, but this one is a little better because I did specify the outgoing interface. So there is not a recursive search to get the outgoing interface. Of course, the router is going to forward something. The router needs the outgoing interface. You need to know what is the outgoing interface. So if you did not specify to the router what will be the outgoing interface, the router needs to search a little more on the routing table to get the outgoing interface. Okay, let's see exercise 72. What two pieces of information are needed in a fully specified static route to eliminate recursive loop? So we need to specify two things, the outgoing interface and the IP address of the next hop. So let's see that. Choose two options. The interface ID of the exit interface, yes, I need that. I need to specify the outgoing interface. The interface ID of the next hop neighbors, no. Okay, if R3 needs to send something to R2, R3 needs the information of this interface, not this interface. Okay, the IP address of the next hop neighbors, yes, I need that. Okay, so the administrative distance of the destination network. So dynamic routing protocol have something that we call a dynamic administrative distance. And it say how good is the routing protocol. The lower is the administrative distance, the much I am reliable. So it's just say how reliable is a routing protocol. The IP address of the exit interface. No, if R3 needs to send something to R2, the IP address of the exit interface, the outgoing interface, is not important. It's the IP address of the next hop that is important. Okay, so the solution was there. Refer to the exhibit. So this one. Let me put it in the same page. Okay, so refer to the exhibit. The routing table of R2 is as follows. We have it here. So let's study it. We are R2. So directly connected, 1, 2, 3. We should have 3C. 1, 2, 3. So we do have 3C. Now, remote network that are not connected to me, 1, 2. So we see a S here and a S here. That's fine. There is 2 remote networks. So just looking at that, it looks like things are okay. So what will router R2 do with a packet destined to this network? With a packet with this destination IP address. So explain me the process of the router. Let's say that I am R2 and I just receive a packet and I look at the destination IP address. And the destination IP address is this one, 192.168.10.129. What R2 is going to do to take a decision what to do with this packet? R2 have to forward the packet, which means that it receives it on one interface and it sends it to another interface. So the packet can continue its route toward the destination. So R2 is going to do what? R2 is going to check if this IP address belongs to those networks. So here in the routing table, we have 5 entries, 3C, 2S. So R2 is going to ask the first question. Is this IP address, which is the IP address of the destination, belong to this network? So yes or no? So this network is 10.0.0.0/30. Is this IP address belong to this network? Yes or no? So we spent 1 month just understanding what was an IP address. So please, what is the answer? Of course, no, it doesn't belong. This network have how many IP address? The first network, the 10.0.0.0/30. It have 4 IP address. It have 10.0.0.0, 10.0.0.1, 10.0.0.2, and 10.0.0.3. By the way, look, it is the network that is there. You see this network? That is directly connected to serial 000. Here is the serial 000. It is there. So only 4 IP address. 10.0.0.0, I cannot use it. 10.0.0.1, I can use it, and it is here in this interface of router 1. 10.0.0.2, I can use it. It is in this interface of router 2. And it also have 10.0.0.3. I cannot use it because it's a broadcast address. Remember, in the network, we lose the first IP address and the last IP address. The first IP address is the network address. The last IP address is the broadcast address. So in this network of 4 IP address, we have 2 valid IP address. This is exactly what I need in a serial connection, because in a serial connection, we can only have 2 devices. Okay, so the destination IP address don't belong to this network. Does the destination IP address, which is 192.168.10.129, belong to this network? Yes or no? So? No, of course no. This network 10.0.0.4/30 also have 4 IP address, which is 10.0.0.4, 10.0.0.5, 10.0.0.6, 10.0.0.7. So 10.0.0.4, I cannot use it. 10.0.0.7, I cannot use it. So I can use 10.0.0.5 and 10.0.0.6. So look at, this network is directly connected to my serial 001. Look at my serial 001, it's there. So we are talking about this network. And we are using the 10.0.0.6 and the 10.0.0.5. Because we cannot use the 10.0.0.4, which is the network address, and the 10.0.0.7, which is the broadcast address. So this IP address is not there. Now, what about this one? Is this IP address belong to this network? So this network appears as a S for R2, which means it's a remote network. So is this IP address, the 192.168.10.129, belong to the 192.168.10.0/26 network? Yes or no? No. So this network go from 192.168.10.0 up to what? Up to 192.168.10.63. So it doesn't have the 10.129. It's go from 10.0 to 10.63. So we are talking about which network? We are talking about this network. So this entry corresponds to this network. So for R2 to reach this network, it have to send it, look at, it say send it out the serial 000. If I am R2, I want to reach this network, I have only one way. And the way is through R1. So I send it out the serial 000. My serial 000. Now, is this IP address belong to this network? Yes or no? No. So in this network, the IP address go from 192.168.10.64 to 192.168.10.127. So this IP address don't belong to this network. So if you look at this network, is this one. And you can see this one is directly connected. They have a C. So this network is directly connected to R2. Directly connected through the fast Ethernet 00. So this IP address doesn't belong to the fourth network. Now, is this IP address belong to the fifth network? Yes. Because the fifth network goes from where to where? 192.168.10.128 up to 192.168.10.191. So of course the 10.129 is between 10.128 and 10.191. So we are talking about this remote network. For R2, it's a remote network. For R3, it's a local network. For R1, it's a remote network. We are R2. This is a remote network. So the routing table say, if you want to reach this remote network, what does the routing table say? It say that, no? So look, this IP address don't belong to the first entry. So it's a fail for the first entry. Doesn't belong to the second entry, it's a fail. That don't belong to the third entry, another fail. Doesn't belong to the fourth entry, another fail. It does belong to the fifth entry. So for the fifth entry, it's a hit. So there is only one hit. When we have only one hit, we don't have choice. We just have to go with what the hits say. So the hits say what? Send it to 10.006. Where is 10.006? It's R3. Send it to 10.006. So what will do the router next? To send it to 10.006, I need to know what is the outgoing interface. Because I have three interfaces. This interface, and this interface. So if I want to reach 10.006, I need to know if I send it out serial 000 or serial 001 or fast Ethernet 00. So I need to know. So now I do a recursive search. It's a second search. I do a second lookup. So now I'm going to look what, if I need to reach 10.006, what should I do? So now I do a second search. Is 10.006 in this network? No. Is 10.006 in this network? Yes, so one hit. Is 10.006 in this network? No, another fail. Is 10.006 in this network? No. Is 10.006 in this network? No. So to search 10.006, there is only one hit. And this hit says, tell me you have to send the packet out on serial 001. So now the router has all the information. It knows that it has to send the packet out on serial 001 to 10006. It has to make two searches in the routing table to get this information. So what will be the answer? Drop the packet. No, I'm not going to drop the packet. I am R2. They want to reach a device here. I already know that I have to send it out this interface to 10006. I'm not going to drop the packet. Send the packet out interface serial 000. Send the packet out here. No, I want to reach this. On the routing table, send it out serial 001 to 10006. So these two are not solution. Then we have send the packet out interface serial 001. This is what I saw. I have to send it out this interface. This is what the routing table says. So look, even if the router R2 don't have the picture of the network as we have it, it could infer that you have to send the packet out serial 001 and send it to 10006 because it have a routing table. Look at the last answer. Send the packet out interface fast Ethernet 00. No, I'm not reaching a device that is in my LAN. This is a LAN. I'm trying to reach a device that is in a remote LAN. So to reach a remote LAN, I need to send it first to R3 on this interface. So the last solution, which is D, is not the correct one neither. So the solution was send the packet out interface serial 001. So you see what is a recursive search? It's when I don't have enough information with the first search, and I need to do a second search in the routing table to get the complete information. I always need the output interface. If you don't know where you go out, it's like you are in a house that have several doors. And they tell you, we want to go to this place, and we want to minimize the distance. So there is one door that is better than the other. You need to know which one. So first, you need to know what is the output interface. Question 74. So they say, refer to the exhibit. So this one. The small company shown use static routing. Okay, this is a small company. Yeah, they use static routing. User on the LAN of R2. So the user that are connected here. You see R2, this is a LAN. This is a WAN connection. This is a LAN connection. Ethernet is a LAN, local area network connection. Serial is a WAN, wide area network connection. So the users that are in this LAN report a problem with connectivity. So they have some problem. Maybe sometimes it's work, maybe sometimes it doesn't work, or for certain place it works and other place it doesn't work. What is the issue? So they show you some command on R2 and some command on R1. So what is the issue? There is a misconfiguration in one of the two routers. Which one have a misconfiguration? So R2 should have 2C because R2 is directly connected to this network and directly connected to this network. We have a C, we have a C. And R2, look at, have a S. So this S is a default route. It says that if you don't want to reach a device that is here or a device that is here, look at what it says. Send it out on serial 000. So if R2 have something for another device, it will send it out serial 000, which is correct. Okay, if R2 want to reach a device here, since it's directly connected, it will send it directly to this device. If R2 want to reach a device here, the only one is R1. R2 will send it directly to R1. And this last S say that in all the other cases, send it out this interface. So if I send it out this interface, I send it to R1. So this is the correct configuration. Don't worry for the L entry. L stands for local. Okay, now let's see the configuration of R1. Is the configuration of R1 correct? Of course, the misconfiguration is in R1. What is the problem in R1? So let's understand what is going on in R1. So it's saying, if you want to reach the network 10.0.30.0/24. So we are talking about this network. 10.0.30.0/24. I am R1, no? So it is directly connected to gigabit Ethernet 0/0. That's fine. So R1 have a correct configuration for this network. Let's see the next one, this C. It says if you want to reach 10.0.40/24, which is this network. So it says it is directly connected on gigabit Ethernet 0/4/1. Gigabit Ethernet 0/4/1 is here. That's fine. So this network and this network are well configured in R1. Let's continue. The next one is this C. If you want to reach network 10.0.50.0/24, we are talking about this network. The network between R1 and R2, which is a serial connection, a WAN connection. So if you want to reach any device in 10.0.50.0, send it, it is directly connected to serial 000. Fine, that's true. So that's not a problem. Then we have another C here. If you want to reach a device that belongs to the network 192.168.96/30, it is directly connected to serial 001. So here, this is serial 001. Serial 001 is this one. So this is the network between the router, the border router of the company, and the router of the ISP. This is also correct. Now look at, by default, for all other network, this is a static route, which means that the network administrator come to R1 and type a command IP route. In all other cases, send it out through this interface, serial 001. So for all other cases, I will send it out to the ISP. Is this well configured? No, why? What will happen if R1 have a packet for this network? What will do R1? For example, let's take an IP address here, 10.0.65. If R1 have a packet for 10.0.65, what it will do? Let's try it. So is 10.0.65 belong to 10.0.30.0/24? Does it belong to the first one? No, fail. Does it belong to 10.0.40.0/24? No, fail. Does it belong to 10.0.50.0/24? No, fail. Does it belong to 192.31.7.96 CS450-2022-03-29. No, fail. Does it belong to this one? Does the IP address 10.065, let's say that this is the IP address of this PC. Does the 10.065 belong to this network? The default network? Of course it belongs. The default network, all the IP address belong to it. So if I have an IP address for the PC that is there, and I'm R1, what I'm going to do is what? I'm going to send it out this interface, serial 001. So I'm going to send it to the ISP. Is this correct? No. If I want to reach this network, I have to send it out serial 000, not serial 001. So the problem is in R1. So what should do the network administrator to fix the misconfiguration of router 1? It should type one more IP route command. And this IP route command will should say what? Let me type it here. When I'm in router R1, and when I'm in the global configuration mode, I should type IP route. If you want to reach this network, which is 10.060, so 10.060/24, what should I do? I should set it out serial 000. So one solution is serial 000. That's it. This is correct. Another solution that will be correct will be what? I send it out 0/000 to, oh, I don't have this IP address. But let's say that this IP address is 10.050.20. I will put here 10.050.20. This is a second solution. A third solution will be what? That I put directly here. The IP address without specifying the outgoing interface. In this case, the router will have to do a recursive search. So any of these three commands will fix the misconfiguration of the router. Put a color, okay. So let's see the possible solution. R2 need a static route to the R1 LAN. So R1 have two LAN, this LAN and this LAN. No, R2 don't have a misconfiguration problem. So R1 and R2 must use a dynamic routing protocol. Not they must, they might. You might if you want. Okay, R1 metric, R1 needs a default route to R2. R1 have a default route to the ISP, which means that, which is correct. For all the other packets that don't belong to my company, I sent them to the ISP. So this is not correct. No, R1 need a static, a default route to R2 is not correct. R1 need a static route to the R2 LAN. This is what is correct, no? Need one of these three commands. And R2 need a static route to the internet. R2 already have a static route to the internet. R2 say that in all the other cases, I send it to R1. Okay, so the answer was this one. Okay, refer to the exhibit. What is the number of broadcast domain? So we have 5 routers. We have a router here, another here, another here, another here, another here. Here we have a LAN that is connected to this router. another LAN with 20 hosts that is connected to this router, another LAN with 12 hosts that is connected to this router, and another LAN, another local area network that is connected to this router. So they ask us how many broadcast domains we have here in this internetwork. So remember, each interface of a router is a different broadcast domain. Each interface of a router is depend. If the router is new, and let's say that the interface is an Ethernet interface, and the interface is full duplex, and you connect another device that is full duplex, in this connection, in this Ethernet connection, we will not have collision. Now, if the router is old and the fast Ethernet interface is half duplex, this interface will be one collision domain. So they are asking for broadcast domain. Each interface of a router is a different broadcast domain. So how many broadcast domain we have here? Huh? How many?
8.
Correct, 8. So let's see. There is an interface in the router here. So this will be a broadcast domain. Here, this connection, which is an Ethernet connection between the two routers, is another broadcast domain. So 2, 3, 4, 5 between the two routers, 6, which is the LAN, 7 between the two routers, 8, which is the LAN, because each interface of a router is a different broadcast domain. So here, this router is connected to 4 different broadcast domains. Now, since this is the same connection, this is the same broadcast domain. This router is connected to 2 different broadcast domains. So this one is shared between these two routers and this one. So we have a total of 8 broadcast domains. Exercise 76, refer to the exhibit. So PCA, which is this PC, sent a request to the server. It is there. It's a remote server, as you can see. What IPv4 address is used in the destination field of the packet as the packet leaves PCA? So look at the level of the PC that has just one interface, they give you the MAC address and the IP address. At the level of the switch, they give you also a MAC address and an IP address. At the level of the router, in this interface, they give you a MAC address and an IP address. So they say that PC4 wants to send something to the server. So the packet that PCA, send will have what? As a destination IP address. What will be the destination IP address of this packet? So remember, the packets from the source to the destination may do several hops. In each hop, what changed? The MAC address is the one that changed. But the source and destination IP address don't change. So here, I can see a first hop. What is the first hop? It will go from the PC to where? The PC to the router. Remember that this is a transparent switch. It is there, but it is like we don't see it. It's a transparent switch, so there will be a hop. And here we don't know. We might have a lot of hop. They put a cloud to say it's very complex. Don't think about it. So the IP address doesn't change. So the destination IP address, of course, is going to be the IP address of the server. So it will be 192.168.12.16 in all the hop, because the IP address don't change. What change is the MAC address. So if I look at the first hop, which is from PC A to router 1, what will be the destination MAC address? It will be the MAC address of router 1 in this interface, 000B 857F 86B0. What will be the source MAC address? The MAC address of the PC, which is 000B 857F 4700. That will be the first hop. We don't see the bridge. We don't see the switch. It's transparent, so don't talk about the switch like it is not there. We don't see it. Question 77. What does R1 use as the MAC address of the destination when constructing a frame that will go from R1 to the server? So what does R1 use when it sends a frame from R1 to the server? So the destination MAC address will be what? This is a hop, no? This is one hop here. If R1 have to send something to the server, what will be the destination MAC address? The MAC address of the server. Okay? So here we have as option the destination MAC address that corresponds to the IPv4 address. If the destination MAC address that corresponds to the IPv4 address is not in the ARP cache, R1 will send an ARP request. That's true. So this answer is true. So the other should not be correct, no? So the packet is encapsulated in a PPP frame. So this is Ethernet. Here you cannot use PPP. Where can you use PPP? Point-to-point protocol. In a serial link. In this link I can use PPP, but here I will use Ethernet. So in the serial link you can use several encapsulation. You can use PPP, frame relay, HDLC, SLIP, which is SLIP, serial line IP, serial line Internet Protocol, SLIP, SLIP. But here you will use Ethernet. So of course, this is not correct. No, I cannot use PPP over Ethernet. R1 use the destination MAC address of the switch. No, the switch is there, but it's transparent. It's like it's not there. R1 leave the field in blank. No. If you send something, you need to see who is the destination. The destination is the server. I will use the MAC address of the server. If I don't have this MAC address, I need to resolve it. And for that, there is a protocol that is called ARP, Address Resolution Protocol. We have not seen ARP, but we will see it very soon. ARP will resolve an IP address to a MAC address. So through the ARP protocol, R1 can resolve this IP address, 192.168.10.16, to this MAC address, because R1 will need the MAC address of the server. Question 78. Refer to the exhibit. If PC1 is sending a packet to PC2, so the packet go from PC1 to PC2, there is 3 hops. First hop, from PC1 to R1, this is a LAN, this is Ethernet. Second hop, from R1 to R2, this is a WAN. serial connection. So here we can encapsulate with PPP, with sleep, with HDLC, with frame relay, and there is a third hop. It's a LAN. It's Ethernet. Okay, so if PC1 is sending packet to PC2, and routing have been configured between the two routers, what will R1 do with the Ethernet frame header attached to PC1, attached by PC1? So we are talking about PC1 send it to R1, R1 receive a frame, and before R1 sent it to R2, what should R1 do? So remember that a router is a layer 3 device. So the packet at the beginning will go up the stack in R1 up to layer 3. And when it go up, there will be decapsulation. Then the packet will go down the stack in R1, where there will be encapsulation. And R1 is going to send it to R2. So what will happen is that R1 is going to change the layer 2 header, because in this hop, the layer 2 header corresponds to Ethernet. In this hop, the layer 2 header corresponds to a serial link. It can be PPP, it can be frame relay, it can be sleep, it can be HDLC. So I want to have to change the header, the layer 2 header. So let's see what they say. Nothing, because the router have a route to the destination network. Of course, it have to do something, no? So here it's like they say, it doesn't change the Ethernet header. Of course, I cannot use Ethernet on a serial link. So I need to remove the Ethernet header and put a header that corresponds to the serial link. So remove the Ethernet reader and configure a new layer 2 header before sending out serial 000. Of course, this is correct. Okay. Open the header and replace the destination MAC address with a new one. So in every hop, both MAC address change. The source and the destination MAC address change. So it's not only the destination MAC address that I have to change. I have to change both. By the way, in serial link, we don't talk about MAC addresses. In Ethernet link, we do talk. In Wi-Fi, we do talk about MAC addresses. But in serial link, there are other layer 2 addresses. For example, frame relay, call them del-C. Okay? Open the header and use it to determine whether the data is to be sent out serial 000. So the determination, the routing is done in layer 3. The routing is not done in layer 2. Here they say open the header, which is a layer 2 header. No, the layer 2 header will not give me information about routing. Routing is done in layer 3. So this is not a correct answer.